Okay, so what's happening here is now we have 3 cosine theta, which means that we're really dealing with a unit circle that has a radius of 3. So instead of our amplitude being 1 to negative 1, we're going to go up to 3 and up to 3 and down to negative 3. So I'm not going to go from negative 2 pi to 2 pi. Let's go from 0 to 2 pi, just so we can see what's going down here. All right. So here's pi. Here's 3 pi over 2. Here's pi over 2. Right. So then when we travel around our circle, what's happening is now our radius is 3 instead of 1. So then when we're here at 0 instead of being at 1, we're at 3. 1, 2, 3. We're up here at 3. Yay, 3. Okay? We're still going to come back down to 0. That was terrible. Undo. We're still going to come back down to 0 at pi over 2. But then we're going to be down at negative 3. Which we can say is like down here 1, 2, 3, negative 3, okay, negative 3, all right, come all the way down. All right, we're still going to be at 0 at 3 pi over 2, but then at 2 pi we're going to be back up at 3, again because our unit circle is being multiplied by 3 out here. All of our values for cosine theta are being multiplied by 3, which changes our amplitude. Now, this one is a little more interesting, where our period is changing. So the period of our function is changing. So we have theta over 2. So let's say we plug in theta. Let's say we plug in theta equals pi, right? Well, normally sine of pi is 0. But normally if we plug in pi, we're now over here where sine is 0. But because we have because we're doing theta over 2, we get sine of pi over 2. So now when we plug in pi for theta, instead of being all the way over here, we're half as far. We're up here at pi over 2. Let's see what happens when we plug in theta equals 2 pi. Okay, normally that's one full trip. Here we are. But because we're doing theta over 2, we get sine of 2 pi over 2, which is just pi. So now we're half as far. We're only halfway around, right? To go all the way around, we're going to have to plug in 4 pi. Theta equals 4 pi. Normally, that would mean 2 full trips, 2 pi, 4 pi. But instead, because we're plugging in theta over 2, we have sine of 4 pi over 2, which is just 2 pi. Okay? So the period ends up being double the length because we're going half as far every time we plug in an angle. So let's see what this is going to look like. We're still going to start at 0. Here's 2 pi. Here's pi. Here's 3 pi over 2. Here is pi over 2. Okay, and then here's 1, negative 1. Still starting at 0. Still starting at 0. But now when we're at pi, we're actually at pi over 2, as we saw up here. When we're at pi, we're really at pi over 2. So when we plug in pi, well, remember sine of pi over 2 is equal to 1. So we're going to have a nice gradual increase until we hit here. All right? And then at 2 pi, we found that we're actually at what sine of pi is, which is 0. So at 2 pi, we're going to be down at 0. All right, so that's only half a cycle, so we have to keep going. And this is going to be a little bit messed up because it's not letting me scroll over farther. So we're just going to call this 4 pi over here. 4 pi. Oh my lord. Okay, here we go. So the very end here, that's 4 pi. Okay, just know that. Okay, so then that right here would be 3 pi, right? Well, when we plug in 3 pi, we're actually plugging in, because this is sine of theta over 2, we're actually plugging in 3 pi over 2. So, well, 3 pi over 2 is down here, where sine is negative 1. Excuse me. So that means at 3 pi, we're going to be down here at negative 1. And then at 4 pi, that's when we're taking sine of 2 pi, because again, we're dividing by 2. So sine of 2 pi is 0. We're back up at 0. And now our period has taken a full 4 pi to go through one cycle because we did theta divided by 2. And it's all about what we get when we plug in theta. What happens when we divide that theta by 2? How does that affect our period?